So I'm starting to notice a trend where more and more people, institutions, it's across the board, are putting out materials, research, etc., that I can only assume they expect that no one will actually break it down to dissect and that they're just simply publicizing for the news cycle to be published, etc. And this is becoming more and more of a pronounced issue in the AI era, and it's not going to solve itself. So I'm going to make this series to start calling these things out. In this series, what I'm specifically going to do is any research paper that I'm focusing on in this series, I'm going to tear it apart. And I'm going to rip apart their methodology and show you exactly why their methodology is flawed according to my own test results and experiments. If you can produce test results and experiments that debunk this, I would love for that. That would increase this discussion dramatically. I go through, when I see these papers, I test the methodology. That's the very first thing that I do. And a lot of times I don't actually make any videos. I don't do any sort of content on these papers because I can't reproduce the methodology. So rather than going through, or there's something wrong with the methodology. So let's highlight these things. So in this paper, were RNNs all we needed, which was published on October 4th, 2024. They outline essentially a lot of math in this. Right? This paper is very heavy math oriented, which is why I assume that most people would not be interested in diving into the actual inner workings of this paper. But it's very simple if you actually understand the math that they're talking about. So they talk about two mathematical concepts within this: LSTM and GRUs, which are both related to mathematical concepts related to neural networks, and they're classic building blocks of neural networks, would be the best way to put them. They're algorithms related to neural network construction and linear regression. And then so within this, essentially what they do is very simplistic, right? I'll break it down for, rather than getting deep into the math on this, it's simple to me what they do, right? Let's say that you have an equation. Let's look at the equation that they have here. H1 equals 1 minus ZT to HT minus 1 plus ZT to HT, right? And then so you notice here that there's HT and there's HT minus 1. Well, let's just remove that duplicate HT from the equation. Let's drop it, right? We'll use algebraic equations. We'll figure out how we can just drop that extra HT. So then all of a sudden the equation becomes simplified, right? It's HT equals 1 minus ZT in parentheses, and then HT minus 1. Cool. And that's plus HT minus 1 and plus Z1. And then that's your equation, right? You're just dropping that extra H1. And then let's say, like in this equation, this one down here, I like this one, where it's this H1, this tan H, H1 equals tan H linear equation. What if we just drop the tan H? Why not, right? So we can just drop math from the equation. We can simplify these mathematical equations. And then by simplifying these mathematical equations, it has dramatic effect on computation, right? By just dropping the extra H1 or dropping the tan H in these mathematical formulas, and then it's just, one of these formulas in a group of formulas. But by doing that, you're dramatically, when you're running this as Python code, dramatically reducing the computation of these models. Because in these instances, right, when you're doing this equation, let's say that in a processing equation, you have to process this equation 1,000,000 times in order to get the answer. And then so dropping that extra H1 or that HT has dramatic differences when you're doing it 1,000,000 times, right? And then so that's where you get into kind of where you can see the benefits of simplification, and then where you would want to do this, and then where this comes down in their code, and executing it is pretty straightforward in the math, right? So within here you can see that you've got your feed forward mechanism. So when reconstructing this, essentially what I've done is the reconstructed their simplified LSTM and GRU layers that you can see here. And then you can see it's like all the math, right? So HT equals H preview, and then previous, and then HT, all of your math here, right? And this is just all math using the hidden states, noticing that it's constructed as an RNN. So it's only a feed forward network, right? So all of this is only feed forward within this. And then you've got everything here, your GRU gates. I've reconstructed this essentially based off of the methodology of the research paper. And then the very first time that I ran this, I did make with this one up here, the one that I stopped, I'll just highlight and notice. So in the training run, I wanted to make this 100% replicate of this, right? Within this, you notice I have a backwards propagation that I'm doing within the training, which would not be reproducing this effectively 100%. But even within this, right? So within this, I have the back propagation layer in there, and then I ran it. And the first time I noticed, I was playing around with this, I was like, this model's kind of stupid, honestly. Like, it came up with coin flip accuracy, and like it's like 50.48% accuracy. And I was like, okay, that's interesting. And then that's where I start running through the code, and I notice, okay, I've got back propagation in here. So I can't see that actually like decreasing the model performance in this instance. There would be no reason for this to like this extra step here to decrease model performance flat out. But it's something that's not in the research paper, right? So okay, I'm not fully reconstructing the research paper within this, so let me do it again. Let me start over here. So here, cool. Reconstructed, here's your mini GRU, just your feed forward network, right? Here's all of the math that they're doing, all of your simplified equations that you have, and then that you're presenting here within the research paper. I have here on your update gate, the research gate, the candidate hidden gate, the final hidden state, etc., right? Here's all of the math presented in the paper. Training it on the IMDb data set, so hammer spam. It's very straightforward there. And then we go through, and then we just are doing a feed forward in this instance, right? So in the feed forward instance, I'm not actually training the model, I'm just evaluating accuracy. And then when I evaluate accuracy, 49.87%. That's the bottom line here, right? Just highlighting this overall, putting this into simple terms, this model, if you were to utilize it, it would be the same as taking a quarter and flipping it and then calling heads or tails and then determining your outcomes based off of that. Your quarter flipping would produce the same outcomes as this model. And like, what is this, is that worth anything to you at all, is kind of the bottom line that I'm trying to get at here, right? What is the point of this research overall when the model result is a coin flip accuracy, when a quarter, literally flipping a quarter in the air, does as much as your 20-page research paper? Why do we have this 20-page research paper? And this, I'm just calling it out. Like, is this paper and is the mathematical theory behind this paper interesting? Yes. Am I glad that this paper exists? Yes. This paper caught my attention because it gets in my newsfeed, right? And then so just picking it up and then going through, I was like, oh, this is interesting because as someone that is interested in RNNs, I want to double check the math. And then I double check the math and I go through the experiment and then 49.87%. And then so, I mean, honestly, what this does for me is that the next paper that shows math with regards towards RNNs and that comes along my newsfeed where someone is blowing it up, like, is this the potential for RNNs to replace transformers? I'm going to ignore it because of this, right? Like, okay, like I'm going to go through, I'm going to spend 2-3 hours dissecting this paper, understanding their methodology, building this out, experimenting on it, and then I can beat it with flipping a coin in the air. Like, I mean, at a certain point, it's there should be standards for what you're releasing, making statements on overall, things like that, right? I mean, I'm a small researcher, so I give like Borealis AI, Mila University, etc., right? I can't knock any of this because like this is in my camp overall, right? But if we want to keep this, and I will say over like Meta, Microsoft, Salesforce, like I said, all of them are just as they're worse at this. So, but I mean, as the small community, we're going to get more of this backlash than them, right? So I think it's the impetus. Microsoft isn't going to change this approach. So the start is with these smaller researchers, and then so just calling this out again. Not to knock these researchers, if you, I am highlighting research here, right? My research shows that the methodology in this paper and the claim. So the claim that this paper, their major claim is that their methodology makes the model more efficient. That is true. Their methodology does make this model more efficient. It was very efficient to evaluate this model. It took 4 minutes to run it on the whole data set. Fantastic job, right? There are efficiency gains. Does this actually work? It's 49.87% accuracy, bro. Like, you can't claim that it works. You can't claim that it's learning anything. Like, it's learning as much as a coin flipping in the air. Literally, that's what's going on. Like, if it were 58% even, I mean, it's literal coin flip accuracy. What are you supposed to do with this? Like, I mean, like, if it's literal coin flip accuracy, it doesn't work. Like, that's the bottom line. Like this, like you can make it I can make my computer more efficient by stripping out the motherboard. It's not going to work afterwards, but it's going to be more efficient, right? It will meet the technical definition of more efficient. That's what this is. It's the same thing. Like, we don't need these kinds of research papers. And then so I'm just like, this is going to be a developing series. The next paper that I run into where I run into these same exact experiments, I'm going to develop the next video on it. Just happens to be this research paper for this first one. Were RNNs all you needed? No, they're not. Here's my methodology. I'm going to link to it. Please prove me wrong. If you want to comment, do it so with experimentation, right? Here's my experimentation. Here's all of the math behind it, all the code behind it. I'm calling BS because of this very specifically. And then so if you want to call BS on me, call BS on something that's concrete. That's all I ask for. If you like this type of content, please like and subscribe. Thank you very much.